In this lab, we are going to synthesize a mystery alum, and we will be working in a fume hood. Let me give you a better view of our workspace right here. A fume hood will pull vapors from the reaction up and out rather than in my face, and so that'll make it easier to conduct this safely. So I'm going to set this up so we can see right at into our experimental setup. There we go. And so what I've done is I've weighed out some aluminum foil. It's 0.503 grams. So 0.503 grams of aluminum foil. And I've torn it up into these little itty bitty pieces right here. And so I'm gonna take this and pour it into my 250 milliliter beaker. And I'm now gonna add 25 milliliters of caustic potash, which is going to be 3.0 molar potassium hydroxide, which I have here. I'm going to measure out 25 milliliters using a graduated cylinder that has markings every 1 milliliter. These bubbles are going to make it really hard to read the meniscus. So I'm going to try to tap them out a little bit. And I'm using the bottom of the meniscus to read this, and it's sometimes helpful to use a piece of white paper behind it to see it. I'm going to use this filter paper. And it looks like we're actually not quite at 25. I'm going to add a touch more. Now we're just a little bit over, so I have a little of excess, so I'm going to pour this into my waste jug rather than back into the bottle, just in case there's any residue here that would contaminate it. And so now I have something that I think will, I'm going to put this on the edge so maybe we can see a little better. It's pretty hard to read on, there we go. And it's not perfect because I'm holding it up, but it's basically at 25.2.1 milliliters of our caustic potash. What I'm going to do is I'm going to slowly add this to my aluminum foil. And I'll set that aside. Now, what I'm observing, and hopefully you can see this on the screen, is there's lots of very small bubbles in our beaker. I'm hearing a little bubbling noise as well. And now I'm seeing a lot of bubbles. I'm going to feel my flask. It's getting slightly warm to the touch, just a little bit warmer. I'm also noticing that there's vapor coming up right now. And make sure all this aluminum foil is in here. So the vapor I'm seeing is going to be, I'm going to close the sash all the way. What's happening is we're producing hydrogen gas as we react the potassium hydroxide with the aluminum metal. It's actually undergoing a reduction and oxidation reaction to produce a cationic aluminum ion. And this hydrogen gas, we don't want to inhale it, but also it's flammable. So if I were to hold a match or lighter up to the beaker right now, it probably wouldn't catch on fire because the beaker has a rather large mouth and it's pretty open. We challenged ourselves to try to find a way to actually produce a flame once, and it required having it in a closed bottle that had a very small opening, and then we were able to maintain a flame from the hydrogen gas that was evolving. So it's very flammable, but the safest way then to work with a reaction like this is to have it be open into a fume hood and to also have something that has a large mouth, so that way we're not concentrating or pressurizing anything with the hydrogen gas. So we're going to allow this to react until we see all of our aluminum hydroxide dissolve. So I'm going to pause this video while the reaction goes to completion. So the reaction is not complete yet, but I wanted to show you how vigorously the reaction mixture is bubbling. And now we have a lot less of our aluminum foil that is actually intact. And here, let's take a little look at this. So the beaker now is definitely warm to the touch. It's definitely stopped fizzing quite as much. And I'm going to bring this up so you can see it better. So it looks kind of black, right? That's because there's actually a fine black precipitate that is formed underneath it. Let me use something white to hopefully show you. Not the best. So we have a little bit of this black precipitate that's formed. And now most of the bubbling stopped, and we have, I can't see any large pieces or significant sizes of aluminum foil left in the beaker. So what we need to do now is separate our solution, our liquid solution, from that black solid. And we're going to use a Buchner funnel for that, and a vacuum apparatus to filter this. So you can see the setup here. I have, here's my Buchner funnel. I have a piece of filter paper that'll fit perfectly inside it, which I'll place in here now. And this has a rubber stopper that it's fit into, so that way it creates an airtight seal into a large Erlenmeyer flask that has this piece right here that is open to and connects then by a vacuum tube to a water aspirator. So when I turn on the water, we'll be able to create a slight vacuum that will help pull the liquid through the filter paper, which will make it act much, the filtration go much more quickly. And what I'm going to do before we start is I'm going to wet the filter paper with a little bit of water, so that way it sticks to the bottom nice and tightly, so that way I don't accidentally have any of my solution and solid slip through it. And so what I'm going to do now is filter. So I'm going to get a little bit better angle. There we go. Looks good. So I'm taking my solution of my caustic potash, and it's very warm. It's not hot, like I'm not going to burn myself. I'm swirling this so that way I can get my solid suspended in the solution, but I'm being very careful to swirl just slightly so that way I don't risk spilling it. And now I'm going to pour everything out into my funnel, and you'll notice it doesn't start dripping right away. The filter paper is very fine, to the point where this will take just a really long time. And so we will use this vacuum filtration setup to speed it up. So right now I'm turning on the cold water. And when I do that, you can see that it filters very quickly. I'll let this go for a little bit just to make sure I can get as much of my solution isolated from the solid as possible. That looks pretty good. Turning off my vacuum filtration, and now I'm going to pour the contents of the Erlenmeyer flask that I've set up to filter here. So first I need to break the vacuum, and I do this by pulling out the stoppered piece. I'm going to set this aside in the beaker that I had used before, and I'll show you. You can see there's a little bit of black solid that has been collected in the funnel, and I'm just going to dispose of that in our hazardous waste. So I'm going to remove our vacuum line. And this clamped so that way it would be secured. And here's my solution that I'm actually interested in. So I'm going to use just a little bit a Chem wipe. So when I look at this now, and I'll try to zoom in on this, I see that I did not filter out all of my solid. You can see there's still a little bit of black solid in there. So I'm going to repeat this filtration step once again to try to make sure I can really get rid of all of this. Okay, I've cleaned my Erlenmeyer and my Buchner funnel, and I am ready to filter again. And this time, what I'm going to do is I'm actually going to turn on the vacuum before I add the solution. So that way, the filter paper is being sucked by the vacuum, so that way it doesn't have any little pockets for the solid to slip through. And I've also wetted it and made sure that it is as closely adhered to the bottom of the Buchner funnel as possible. So again, I'm going to take my solution that has a little bit of black solid in it, and I'm swirling to make sure that that suspension is not settled to the bottom of the beaker. All right, I've noticed that I'm not seeing any more drips of solution from the funnel into the flask. So I'm going to assume my filtration is complete. I'm going to turn off the water, and I'll break the vacuum. And let's take a look. And we can see that we've collected quite a bit more of that black solid. And so the trick there was starting the vacuum, having wet filter paper, so that way it was being pulled by the vacuum onto the bottom of the Buchner funnel, so that way there was no way that solution could go around the filter paper rather than through the filter paper. All right, so we're going to dispose of this filter paper in our hazardous waste container. And then I will clean this Buchner funnel, and we're going to take a look at what we filtered here and compare it to what we saw before. I have a clean 250 milliliter beaker. Now I'll get something white to put underneath it. You can see that or hopefully you can see on the video, it's very clear now. So there's no indication that there's black solid that remains. It's a clear liquid, so our filtration has worked. For the next step, I'm going to want to have my reagents added to one another cold. So I'm actually going to set, I've created a little ice bath, and I'm going to set the beaker that we just collected our material into in this ice bath just to cool it down. And an ice bath has mostly ice and a little bit of water, and that water is just to make sure that we actually surround the beaker completely with the same temperature, and so that way heat can flow out of the beaker and into that water efficiently. So we're going to be adding then vitriolic acid, and we would like to add that at a cold temperature as well. I've been letting my reaction mixture cool, and now I'm going to measure out the next reagent I need, which is going to be vitriolic acid, which is really 3.0 molar sulfuric acid. So looking at that, I think it's pretty close to 25. Let's measure this volume together. Try to put something behind it that's white to help you see it. So I know that's pretty hard to see the white letters on the white background, but it's very close to the 25 mark. In fact, I'm reading the meniscus at 24.7 milliliters. 24.7 milliliters. Now I want this to be cold as well. My next step with my reaction mixture, I need to add something to that first. So it's been cooling. I paused the video for about 5 minutes. I'm gonna add this victrolic acid carefully to a large test tube. You could also use a small beaker. And I'm gonna try to cool this solution in my ice bath. So now I've got this cold solution. I'm going to go ahead and add a few drops of methyl red. I'm going to add 10. So here is a 1% solution of methyl red. And this is an acid-base indicator. Now, this indicator will be yellow under basic conditions, and it'll be red under 4, 5, 6, 7, 8, 9, 10. And it'll be red when it's acidic. And so far, our reaction mixture has had just potassium hydroxide, which is a base, and aluminum added together, but they reacted and they produced hydrogen, but we can still see the overall mixture is basic because we have this beautiful yellow color, which means we have a high pH. So to this, I'm going to add my cooled victrolic acid. I'm going to give it another couple minutes to cool down. And so I'm going to pause for just a second and then we'll do our addition. Okay, I have the reaction mixture in a separate ice bath. It's been about 3 to 5 minutes. So I'm going to bring these together. I'm going to do our addition. So here is our yellow basic solution. I'm going to put something white underneath this so you'll be able to easily see any color changes. Well, that's not very white anymore. So we expect to see a color change as we add the acid. During this portion of the lab, it's really important to take observations of the changes that you see in the physical appearance of the mixture. I'm going to be stirring while I add this. So I've got my cooled victrolic acid here. I've got a stir rod to stir with. The reason we've cooled these two reagents is it's a pretty exothermic reaction. And so we want to have them cold so they don't get too hot. You can see that we've no longer have a yellow solution. It was first a cloudy pink. It was almost gel-like. And now the consistency of it is a lot more liquidy. That kind of gelish consistency is broken up and changed, so it's very pink. Remember, our methyl red indicator tells us that when a solution is yellow, it is basic or at a high pH, and when it is red or pink, it is more, or when it's red, it is acidic or a low pH. So there is a solid in there. You can see maybe if I see it on the walls after I swirl it. In this solution, breaking solution. Now that I've stirred for a little while, I'm going to try to assess if there's any of this solid left over. It looks like there might be. It looks a little cloudy. I see a little bit of white floating. And so sometimes that solid completely redissolves and sometimes it doesn't, and that's normal for this reaction. So we're going to use our Buchner funnel again to do a vacuum filtration to separate that solid from our solution, our reaction mixture. So I'm going to pause the video and set that up again. All right, I've set up a clean Buchner funnel into an Erlenmeyer flask, ready to pull a vacuum on it to filter our pink solution. So I'm going to turn on our cold water and start that vacuum. You'll see a few drops just from the water I've added to the filter paper to secure it to the funnel. And now I'm going to take my solution, which definitely has precipitate now that I let it settle for a second. And I'm going to swirl it to try to suspend that solid as best I can. And I'll pour it into my funnel and let that filter. And I should get a pink solution without any solid material in it at the end. We'll pause while this filters. It has taken a couple minutes for our solution to completely filter through the funnel. We no longer see any drips, so we're going to assume this is done, and I'm going to turn off our cold water. And let's take a look. Let's break our vacuum by pulling off the funnel, and let's take a look inside. You can see there's a little bit of a pink color. You can't see very well. There's just a very fine pinkish solid at the bottom. And I'm going to throw away this filter paper into our waste disposal jar and set aside our Buchner funnel. Now we're going to collect our solution in another beaker, and I'm going to use a smaller one because I've run out of 250s. So here we'll collect it right here for our next step of our synthesis. So hopefully you can see that we now have a very clear pink solution. In the next step, what we want to do is we want to reduce the volume of this. We're going to try to crystallize it, and we have about 60-ish milliliters, and we want to have more like 50 or less. So that way we have a concentrated enough solution of our mystery alum that we can separate it from the methyl red and the other components of our reaction mixture that are not our product by crystallizing it. And so to reduce the volume, what I'm going to do is take this and let's move our setup to a hot plate. And what we're going to do is we're going to boil off, essentially, the water until we have, so I'm turning this on medium-high, and we're going to just let this boil until we have a solution that's closer to about 50 milliliters. So we're just going to reduce our volume. And the old saying is a watch pot never boils. So I'm going to pause this and walk away and clean some glassware while we're reducing our volume and setting up the next step for our crystallization. Okay, we've now reduced the volume of our solution to actually about 40 milliliters, which you can see here on our beaker. We're at the mark in between 20 and 60, so it's going to be 40. And I've let it cool to almost room temperature. It's a touch warm still, and maybe my impatience will not be rewarded. So I'm going to set my hot plate aside. And now what we're going to try to do is crystallize our mystery alum to separate it from everything else that's left in our reaction mixture to purify it. And what I have here is another ice bath. It's, again, mostly ice with just a little bit of water. And I'm going to set my beaker in on here so it cools. I'm actually going to put a little bit more ice in. And the idea is we're going to let this cool untouched for about 15 minutes or more to try to get, we want to slowly bring the temperature down to decrease that solubility, so that way we can have a solution that will become, or sorry, the alum will become less soluble in the solution. So I'm going to keep an eye on this and make sure that I adjust the ice as I need to, and that not too much of our ice melts so that this doesn't all tip into the ice bath. Because right now that beaker is basically just setting on the compacted ice. So I'll keep an eye on this, and I'll pause this and we'll come back and check for crystals. So let's take an initial look at our solution. So right there, it looks like before we've just started out, it's still basically at room temperature. and we'll come back and look at this in a few minutes. It has been 10 minutes, and let's just take a little peek at what's going on. We might need to wait longer, but I just want to let you see the progress along the way. It looks kind of the same. So at this point, without any crystal growth, I'm going to let it go another 5, and then we can check it again. And then we'll start talking about strategies to help a crystallization occur when it doesn't seem to want to go. I'm going to pack a little bit more ice in this since it hasn't happened yet. Actually, I probably won't. I'm going to leave it for another 5, and we'll pause and come back in a few minutes. Okay, it has been 15 minutes in the ice bath, and let's take a look. There are not any crystals in there. Now, if you were doing this lab, you might have had quite a bit more luck, and you might have a big pile of crystals. I personally have really bad luck, so I'm going to show you a few different techniques for helping encourage crystal growth. So first, what we're going to do is we're going to take this out, since disturbing it at this point it is less important. We're going to make sure that our ice bath can maintain for a longer period of time by pouring out some of the water and adding more ice. And then what we're going to do is scratch the bottom of the surface of the beaker, and our hope is that that will create a little bit of an inconsistency in the glass, so that way we can I get this in the ice bath, so that way the crystals have a place to take hold. So I'm just scratching the bottom, one scratch, and I'm pulling it out, and I've got plenty of ice in my ice bath. And I'm going to walk away for another 5 minutes at least, and then we can come back and check it again. Okay, it has been about 5 minutes, and I just want to check on the progress of our crystals. So we've scratched the bottom of our surface. And it looks like we haven't been very lucky, which again speaks to my general bad luck with crystallizations, but also we get to show off another technique for trying to form crystal growth. So in this case, we are going to try using a seed crystal. I am going to get a spatula, and we happen to have a couple of our collected crystals that we've saved from past labs. And so I'm actually just going to try to just take 1 or 2 of the actual crystals of this and add it to our solution. And then this allows the cations and anions in solution to kind of nucleate onto this little crystal that we already have. So I'm going to just tap that in. All right, a few of those went in. So now we're going to wait at least another 5 minutes, maybe 10. So we'll be back. I'm going to hit pause, and we'll come back and look at what has happened. Okay, we've now added seed crystals and waited a significant amount of time. It's actually been an additional 15 minutes. And now let's take a look. It might be hard to see, but there's actually crystals on the bottom. So I'm going to actually show you by taking this out. So see at the very bottom, we've got crystals that are growing. There, you can see it there. And they're clear. So what we're going to do now is we're going to separate the reaction mixture from the crystals that we've isolated. There we go. And so we've set up our Buchner funnel again, and I'm actually going to use my ice bath to add some 50% ethanol, and I've got it cold. It won't dissolve the crystals, but I just like keeping things similarly at the same temperature. So we're going to add this to our funnel, and we're going to filter. And once we've filtered off all of the liquid, we're then actually going to rinse it with that ethanol mixture, so that way we can kind of clean the crystals of any excess of that liquid from them. So I'm going to turn on the cold water and then add our crystals. Now I'm going to swirl to try to get them suspended. The goal is to get everything out of this and into here. I didn't get quite everything, so I'm going to take a little bit of my ethanol and add it. I'm actually going to do that again because it is really sticking. And I'm going to scrape the insides. All right, I think I've got them all. We're pretty close. So we're going to let this filter. It's going to go slowly because the crystals are going to create quite a bit more of a clog on the filter paper. So I'm going to pause this while it filters, and then we'll come back when it's done. So we've been filtering for roughly 3 to 5 minutes, and I'll show you what it looks like. We've got most of the liquid out, and the crystals look really white now instead of pink. There's still a touch of a pink color to it that might not come out on the video. But I'm going to add, now that it's mostly dry, a little bit more of the ethanol. It's a 50% mixture of ethanol and water, which we know our crystals are not soluble in. And I'm going to pour it on there just to give it another wash to try to get rid of all of the other things that are on there. And so we'll let this go, and then once the ethanol stops dripping, we're going to let air pass through the crystals in the filter for a few minutes to help them start to dry. And then after that, we'll take them out and we'll take a look at what they look like. So I'll pause again while we wait for this to filter some more. Okay, we've let this filter, and we've been running just air through the crystals with this vacuum device for a few minutes now. And so we're going to turn off the filtration, and we're going to collect these crystals. So I'm going to break the vacuum carefully. And you can see they're very white, which is fantastic. Now I have a little watch glass here, and I'm going to try to pull the filter paper up and carefully transfer the filter paper and all of these beautiful crystals onto the watch glass. Oh my goodness, we got a lot. That makes me super happy, especially because it seemed like it took forever for it to crystallize, and it looks like so much more than it did when it was in the solution. And my guess is we really couldn't see a lot of them when we were looking at them inside a pink solution. However, you can see we have quite a few sitting on top of that filter paper there. And now these are still a little damp, and so we're going to let them dry for a week before we use them in the second step phase of this lab, where we're now going to characterize it and determine what it's made up of. And so we will do that in a week's time, and we'll have a separate video for the characterization of our mystery alum. At that time, we'll also weigh our mystery alum and see how much we were able to collect and isolate.